In an earlier example, we have two schools with drastically different GPA system, and the university was looking into admitting only the top 0.5% from each school. Using the known properties of normal curve, we found the top 0.5% for school A with those with GPA greater than 3.9, and the top 0.5% for school B with those with GPA greater than 8.5. While such info are indeed helpful, the reality is that this example is too simplistic because only two schools are involved. What happens if we need to vary the admission criteria, say for the top 1%, top 5%, or top 10%? Different normal curve for different school with different mu and different sigma would mean that we need to use many different statistical tables. If we have 100 schools, that would mean 100 different statistical tables. This can be very tedious and error-prone. Is there a way out of this? To solve this problem, we should standardize the normal curve by expressing x in terms of the number of standard deviations away from the mean. Once everything is standardized, then all we need is just one statistical table for all our calculations. Any normal distribution can be converted into a standardized normal distribution by subtracting the mean from each observation and dividing by the standard deviation. By doing so, a random variable x, which is normally distributed with a mean of mu and a standard deviation of sigma, becomes standardized as a random variable z, which is also normally distributed but with a mean of 0 and a standard deviation of 1. So how exactly do we convert to standardized normal distribution? We begin by finding something called the z-score, where we take the value of the observation x, subtract it by the mean mu, and then dividing it by the standard deviation sigma. The result is a z-score that indicates how many standard deviation that x is away from the mean. Referring to our earlier example, let's try to convert the x-score from the different schools to z-score by using the z-score formula. For school A, if a student has a GPA of 1.5, the z-score can be calculated to be 1.5 minus the mu of 2.7 and divided by the sigma of 0.4 to get -3. Do the same for the other x-scores. For school B, if a student has a GPA of 3.7, the z-score can be calculated to be 3.7 minus the mu of 6.1 and divided by the sigma of 0.8 to get -3. Do the same for the other x-scores. By doing this, most of the students would have a standardized z-score of between -3 and +3. So by standardizing every student's score to a z-score, we only need one z-distribution curve. Now, if the university wants to admit only the top 0.5% of each school, how should they select the students now? Since this is a standardized normal distribution with a mean of 0 and a variance of 1, 99% of students would have GPA that lies within 3 standard deviation from the mean 0. That leaves us with 1%. So each tail end gets 0.5%. And this top 0.5% is what the university is looking for. The university would then admit those with a z-score of more than 3, regardless of which school or which GPA system the student came from. Compared to what was done previously, where we use at least 2 statistical tables and pick up those with GPA of more than 3.9 from school A and pick up those with GPA of more than 8.5 from school B, this is neater and less prone to error.